Okay, I'm going to give you the overview. We'll make it through 2.1. I'm not so sure about 2.2. Okay, you guys know that matter is anything that occupies space and has mass. And so that means that things that are not matter, that's a little bit, that's better, would be things like light and sound and heat, okay? And when we're talking about matter, we like to use their properties to describe them. And properties could be a number of different things. We have extensive and intensive. Extensive depend on how much we have. Some examples would be mass, volume, the electrical resistance of a metal wire, because that depends upon how thick it is and its length. The flexibility of a metal sheet, which depends upon how thick it is. Some other extensive properties which I'm going to list would be thermal energy, thermal expansion, and heat capacity. We will talk about heat capacity later, more in depth. I'm just listing these things now so that you have them, okay? Intensive properties don't depend upon how much I have. So if I have a pure substance, like its melting point, its boiling point would be the same, as would its density. So here we've got melting point and density. Other intensive properties would be temperature, concentration, and tension. I'm going to list some other intensive, I meant to change. I'm going to list some other intensive properties down here. We're going to put coefficient of thermal expansion, which you will probably never, ever see anywhere, but I believe it's in this book, in one of the review questions, and then specific heat capacity. So we're going to be talking about the difference between heat capacity and specific heat capacity later on, okay? All right, so every substance has a unique set of intensive properties that we could use to identify it. We're going to turn to the next page and take a look at physical and chemical properties. Okay, so physical changes are changes of state. So that means if you're changing from a solid to a liquid or to a gas, those are changes of state. Physical properties describe physical changes or a physical quality of something. So the melting point, boiling point, color, and hardness would all be physical properties. Then you have chemical changes. Chemical changes are when a new substance is made, okay? Chemical properties describe chemical changes or the tendency of something to react. So chemical properties would be things like, how stable is something? Is it flammable? Is it toxic? Does it react with other things? Does it rust? Does it decompose, etc.? Let me see if there's anything else in here. Other physical properties would be things like temperature, density, viscosity, and surface tension. I want to draw your attention to the word viscosity. Viscosity describes the thickness or how readily a liquid flows. So if we're dealing with a really thick liquid that flows really slowly out of a container, it would be viscous. So things like molasses or motor oil or honey would be examples. And you can actually make it become less viscous by heating it up, because heating it up would break the intermolecular forces between the molecules, okay? Surface tension is generally something that's going to hydrogen bond, like water molecules. They form sort of like a bead if you find it on different surfaces, or at the top of a water glass. If you fill water up to the brim, you'll notice it forms a dome shape, and that's because water has tremendous surface tension caused by its strong intermolecular forces, okay? Okay, let's take a look. Oh, let me make a couple of other notes before I leave here. Physical changes are usually reversible, and they don't typically take a ton of energy, okay? But if I'm talking about chemical changes are generally not going to be reversible. So if I burn a piece of paper, that is not reversible, and it usually takes a lot of energy in comparison to a physical change to make a chemical change happen. We good? Okay. Let's come down here. Oops. Go away. There we go. Physical changes generally involve repositioning particles. Chemical changes involve regrouping atoms. So physical changes change intermolecular relationships. So whatever the intermolecular forces are between the molecules, those will likely change because we may pull them apart further and further apart as physical changes occur. Chemical changes are going to alter intramolecular relationships, those within molecules. Intramolecular is referring to things like bonds. So we're looking at ionic or covalent bonds breaking and maybe reforming when we form products. Does that make sense? Okay. And then here is the part that I told you up above. Physical changes generally involve less energy than chemical changes. And I think that's all I will point out there. Let's turn the page. If I were to ask you to draw me a picture of particle relationships between physical and chemical, would you know what I was talking about? Or no? It's fine if you don't, just tell me. No. Okay, so if I have a solid versus a liquid, and I said, show me a particle diagram, meaning draw me some atoms or some molecules that show me what this looks like. You know that solids are closely packed, right? Liquids would have more space in between them, so they'd look something like this. You get the idea, okay? And then if it was a gas, obviously there's a ton of space in between the particles. They're very spread out, okay? If we're talking about a chemical change, so that's a physical change, right? Physical changes. But if it's a chemical change, and I'm starting out with like, those are my reactants. To show a chemical change, I would need to show something like this on the product side, where they actually came apart and they regrouped themselves differently. Does that make sense? Okay. All right. Now we can go to the next page. The reason I bring up particle diagrams is because you may be asked to draw something like that in the free response section or interpret it in a multiple choice question. Okay. Okay. On the next page, they start talking about energy. Kinetic energy is energy of motion. So it's not stored energy. So the greater the speed and the larger the object and the larger its mass, then the greater its kinetic energy. You will often see kinetic energy abbreviated as KE. And kinetic energy that exists in particles of matter is called mechanical energy, and that's because they're constantly moving. So they have 3 different types of mechanical energy or 3 different types of motion, okay? They can have translational, which means they move from place to place. They can rotate, so that means they move about an axis, and they can vibrate in place. When you're in the solid phase, the only motion or kinetic energy or mechanical energy that you have would be vibrating in place or oscillating in place, okay? Thermal energy is if I add up all of the motion in a sample of matter. So all those particles' motion would get added together. And then this would be considered an extensive property because it depends upon how much I have. And then, what else? Temperature would be the average kinetic energy or average mechanical energy of particles that make up a sample. This is an intensive property. And then if I increase the temperature, you know that the speed of the particles is increasing in a sample of matter. And then I think that's it for that page. Let's go to the next page. We obviously use thermometers to measure the temperature of a sample. Heat is something that moves from a warmer object to a cooler object. So that means this is the energy that is transferred from one thing to another because their temperatures are different. And then when you guys are doing an experiment, you should know that you put the temperature probe in an experiment at the beginning because our temperature probes have a metal wand, and that metal wand is probably not going to be the same temperature as whatever it is that we're measuring. So you want to introduce it initially so that you're not introducing it a different temperature later because heat could move, right? From maybe our chemicals to the temperature probe or the temperature probe to the chemicals. All right, let's talk about the 3 states of matter. So 3 states of matter are solid, liquid, and gas. Basically what you should know is that for solids, they have a fixed or definite shape. They have a fixed or definite volume, and they have the lowest kinetic energy out of the 3 states of matter. Liquids will take on the shape of their container. So they have indefinite shape, but they do have definite volume. These would be medium in terms of kinetic energy, meaning they have more kinetic energy than a solid does, but less than a gas. And then gas particles do take on the shape of their container as well, and they do take on the volume. So they can expand, and then we can also compress them. So because there's so much space in between particles, and these have the highest kinetic energy out of the 3. Let's turn the page. We're almost done with this section. Remember that when we are explaining what happens to the motion of particles during phase changes, we're using something called the kinetic molecular theory. Kinetic molecular theory is abbreviated KMT. You should know all the points. Matter is made of particles. There's empty space between particles. Particles are constantly moving. How much they move depends on their state of matter. Particles move because they have energy. The energy that they have determines how fast they move and how far from each other they move. Okay? Now, when substances are changing state, we use certain terms. Those terms are listed here. Okay? You should know that evaporation is also known as vaporization. And then if you take a look at the figure that's at the bottom of this page, one side is absorbing energy, the other side is releasing energy. So on the right-hand side, it says add heat. That means that these 3 processes are absorbing heat energy. So this would be the endothermic side. So you have to absorb energy to convert a solid to a liquid and a liquid to a gas. On the left-hand side, this is where we remove heat. This would be where they release heat to convert from a gas to a liquid and a liquid to a solid. So these would be exothermic processes. Okay? Is that the end? No, there's more. Okay, let's turn the page. Okay, we have this and that. Okay, let me stop this.